Smarter than me. So I just want to talk really quick about kind of some of the problems in the industry that we're all addressing, which is number one, elasticity in the network as we move things to the cloud and things that we hope the edge will solve for, the elasticity in the network to be able to expand and contract as necessary. Centralized configuration control. I think we're seeing that across a lot of platforms. That's definitely a desire of end users. Security should be the number one in this list, but for whatever reason, it just doesn't sit at the top in conversations. And then quality coupled with proof, right? So if you're gonna do something for me, put your money where your mouth is and show me that you actually did that. And then all that, I want all these things, and then I want it to cost a lot less than what I'm spending today, right? And so who, if I can ask, who's familiar with the term SD-WAN in the room? Have we all kind of heard SD-WAN, the majority of us, right? So when I think about SD-WAN, I think we're trying to solve for a lot of what's going over the internet, as opposed to what was traditionally on terrestrial or private networks from service providers. But when I really think about SD-WAN, I think, well, what is it? Well, it's load balancing, right? There's some load balancing. And I've been in the industry a while, I can tell you that's not new, right? We've been load balancing for a couple of decades, load sharing, whatever you want to call it. What about IPsec? IPsec is not new. That's something that we've done for a while as well, right? Encryption, we've been doing it for a long time. What about application aware, being application aware? Well, that's what firewalls were built for from day one, to look all the way down the stack, look into layer 7, right? So I don't know that, I keep thinking, I'm saying, you know, QoS, I don't know, is there something, what's innovative about SD-WAN? I don't know what's innovative. What happened is that some folks were pretty smart and said, let's put it all together, things that we do today on different devices, on different platforms, let's put it all together and let's make it digestible. Right? Let's help the network administrator to be able to execute all of these things in a much easier fashion. And so they front end with, you know, some SDN, some telemetry network on steroids and centralized controllers, and they give you a nice portal and call it a day. But the underlying technology really hasn't changed. They just made the interface a little bit easier. What about autonomous cars? We've heard of the term autonomous cars, right? We're in the Bay, so I know everyone in here has, probably before me. But what is an autonomous car? I mean, I think autonomous drone, autonomous car, autonomous vehicle. Well, I don't know about that either. I question that because of the fact that, you know, I heard someone, I think it was actually Mr. Chen from Andreessen, he said if it were autonomous, I think I was telling Debbie this, I say if it was autonomous, it would tell me, you're not going to Dunkin' Donuts again, Wes, you're going to the gym, right? But in reality, it's a programmable, it is an automated device, but does that mean it's truly autonomous? I don't know about that, right? So I'm not gonna tell Ali to change the slides. He's not my servant. So we came up with a product that we've called our AI WAN. You can imagine what that stands for, Artificially Intelligent Wide Area Network. And as opposed to saying we've got the newest thing on the block and we're the best thing on the block and we're changing everything, all we did was adopt all of these technologies like SDN and NFV and things you guys hear about and SD-WAN that I talked about. And we incorporated machine learning and we incorporated industry standard network topology, RFC compliant, like, MPLS and VPLS. I'm gonna tell you how that all comes together. But the point of this is we just feel we're kind of the next evolution in network architecture at the core and at the edge. So this is our current footprint today. We're in 65 data centers globally. We leverage about 20,000 nodes globally. And what we do is we collect data. We just collect data on the internet, on the entire internet. On every ISP on the planet, we collect data. Congestion, jitter, latency, packet loss, throughput, availability, all of that. Real time, historical, we collect all that data. And what we did with that data is we created the AI WAN platform. So we leverage all of these ISPs that you see on the screen here, and we determine what's most optimal from a connectivity perspective. When a Netrolix device connects to the network, say you order a Comcast connection at your home or your office, CenturyLink, whoever you may use, what our platform does is it looks geographically at the 6 most optimal data centers, and then it down selects the 3 based upon all of those factors that I talked about, right? The real time and historic jitter, latency, throughput, all of those things, and it determines what are the 3 most optimal, then connects that device to all 3 using a 5-factor mechanism to create, you'll see virtual circuit, IKEV2 is part of that, HSM, which is a hardware chipset, an elaborate KMS platform for rotating keys, and then the AI element behind that, and some radius attributes as well to create that virtual connection, right? I'll never say we're impenetrable because it's putting a target on my back. I know better, Ali. But anyway, so those 3 connections are established, and then from those 3 connections, we then rank those 1, 2, and 3, 1 being the most optimal. That whole process I just talked about happens within a matter of seconds, and it's done every 5 minutes constantly. And every element of the network, every storage instance, every configuration, everything has its own unique encryption key that is rotated consistently. So there's no flat network, there's no shared encryption key, right? And so when you think about that, well, how do you optimize on the edge? Because everybody can kind of see data center to data center and that sort of thing. But the fact is, and I use Comcast as an example, but it could be AT&T or anybody. The fact is who connects to Comcast? And how many paths are there into Comcast from other service providers? Just here locally, a lot, right? And so, you know, Einstein said, and I read this a couple of weeks ago, that there are 2 infinite things on the planet, or 2 infinite things, period, one of which is the universe, that's infinite, and the other of which is human stupidity. And he said, I'm not so sure about the universe. And so what we learned very quickly is that as soon as we get out of the way and let machine learning start taking over and let machine learning start making those decisions that we could never do from a brick and mortar, perspective, then things really took off for us. And that happened once we got to about 18 data centers and we were running our own algorithms. And now we've got a model that's essentially 85% accurate without any sort of corrective behavior at all. And I think that's pretty powerful, So to the right there, you'll see 3 different types of access methods. We're an OpEx, not CapEx company. One is, we're just a NID. We just deploy a device on site. You connect from that device to our edge, and you stand up this global AI-WAN fabric. The second of which is, well, you don't want to, you want new equipment. You want to use Netrolix equipment. You don't want to use your existing equipment. We can be the router, the switch, the firewall, the access point. We can be all those things, all managed, and Ollie's going to show through our portal. And then the bottom there, which is the MEC, it's a buzzword, but that's multi-access edge compute. That's mobile edge compute. That's just edge compute. And so, this AI-WAN fabric, we want to be able to optimize flows between data centers and endpoints. And, facial recognition doesn't need to go to a data center every time. It's stored locally. That's on my iPhone X, right? So same idea, right? Or it's HBO that pushes the whole season of Game of Thrones to you because of the fact that you watched 2 episodes, right? It's a little bit of machine learning in there, right? Can we go to the next one? I said I wasn't going to do that. Thanks. So use cases, right? There's obviously the wide area network in general, 2 locations, 10,000 locations, it doesn't matter. IoT, right? I think that's something that we don't address in the network piece. A lot of times I see these presentations of this, you do this in the data center, and then you do this in the sensors and the on-site architecture, and I think we forget about the network. We just IPsec, or we do a firewall, or we do whatever's handed to us just to make it work, and we focus on the endpoints rather than focusing, and that's where we play. We play in the network, right? We play in creating that fabric. So whether it's drones, which is one of our use cases today, we're going to talk about whether it's connected vehicles, whether it's smart cities, right? I think I was talking to maybe, I don't remember who it was, maybe it was Ryan, about maybe cities starting to sell air, sell Wi-Fi, right? And have connected vehicles connect to that, right? So let's go to the next one, Ali, if you want. So what is our AI-WAN? So let's talk a little bit more about what that platform is, right? So it's a completely private and encrypted end-to-end network, right? Leveraging the internet, right? So we have no core. So when you saw the map earlier, there's no lines between all of our data centers. The reason is because when I cross the Pacific Ocean, I leverage every trans-Pacific cable system, whichever is most optimal, right? So transatlantic, same thing, right? We provide VPLS, MPLS, Ethernet services on our AI-WAN fabric. So picture our AI-WAN fabric being a container, that you deploy services on top of or within, i.e. MPLS. And we felt like we didn't want you to have to adopt a new technology. If you want a routed network, then you have MPLS. If you want to use routing protocols, no problem. We honor all of that, right? If you just want an Ethernet network, no problem. We didn't want you adopting some sort of a new topology as well as a new technology. So we wanted to make it simple and provide, RFC compliant services. Essentially, what we like to say, sometimes we like to say we harnessed the internet or we eliminated the best effort mantra of the internet. And the fact is, we have done that, right? And so Ali's gonna spend some time on our portal. Everything is centrally managed. I think the driver's seat looks a lot different than the car on the outside often. And so he'll spend some time on that. I say 100% uptime. I heard a term thrown around called fail operational. That's what we are. We don't go down, right? We had a customer on the West Coast, about 600 locations. They said, well, you got some 8 data centers out here. What if we can't get to one of those? I don't know if that's enough density. And we said, you know what? Look, if you can't connect to a Netrolix data center, 8 of them, you should look for your wife and kids, because something significant has happened, and it's not us, right? So full segment routing, that's another thing that's huge for us, right? We can't exist on flat networks, right? You look at Target, hacked through their thermostat. You look at Anthem, Home Depot, right? Smart refrigerators compromised. And that's because we're running flat networks. And so with our platform, we're able to operate into the LAN as well and extend that network segmentation into application intent-based routing from the LAN into different, say, MPLS VRF or switched instances across the entirety of the network. So take, like a Walgreens or CVS that may have 6 VRFs in a given store, right? One for pharmacy, one for payment transactions, et cetera. And those types of things are able to be segmented beginning at the LAN and then across the network, which offers another layer of security as well, right? And then edge compute. That's a big thing. A couple of years ago, we just said, wouldn't it be a cool idea if on this bare metal, hardware and Intel chipset-based devices that we're loading our software on, wouldn't it be cool if we just put some available cores on there? And we just called them extra cores. I don't even think we had a name for it, right? We just call it extra cores. Right? It doesn't have the ring that Mech does, right? But a couple of years later, people started calling it Mech, and we said, okay, let's call it what people are calling it, right? Which is Mech. Which is the fog layer. And then, I even heard some conversations about the mist layer. It was a new thing, right? The mist going into local VPU and actually into the sensor, right? Operating at the sensor level. And that's where operating into the LAN becomes very important. So let's go to the next one. I said on the first, in the beginning when I started talking about, what folks are looking for, but security is a huge topic, right? And that's why we went with our own platform. We went with our own platform because of our security posture, because of how often we rotate encryption keys, because of the encryption standards we use, because the fact is, look, if I would have told you last year at the beginning of 2017 that the NSA, the FBI, the CIA would all suffer some sort of compromise or breach, you probably would have demanded that I had some kind of drug test or something, because that could never have happened. But that did happen last year. And this year is going to be bad too. A lot of big network providers and equipment providers are already getting hit this year. Right? We're no different to that. So that's another value for us, being able to go into a bare metal environment, leveraging our own software. We don't rely and put our security in the hands of anybody else but ourselves. Right? And our end users, obviously. So like I said earlier, some of the factors that come into negotiating that connection with us is the HSM, which is that's that chipset that you'll see primarily in the financial sector, right, in the credit card. And then the KMS platform. And then machine learning. We were going to do what we called our security shield, but we realized very quickly that should just be inherent to the platform, which is essentially looking into the network. So I can go back to Target as an example. We would have seen that, hey, that MAC address belongs to a thermostat, not that Linux box sitting behind it. There's an irregular flow coming from that device, right or wrong, it's an anomaly. There's irregular destinations for that traffic. That's right or wrong, that's an anomaly. Again, all these flags would have arisen, and what would have happened is someone probably there would have said, hey, that's weird, let's look at that. And it wouldn't have gone 280 plus days and $500 million in liability, right? So some unique things there. And then blockchain, something we're looking to. I think it's important to say we didn't just make it, we didn't arrive at this, and here we are. So we're in the process of looking into some blockchain technologies to further bolster our security posture as things begin to progress more and offer things, some really unique things like private blockchain across a private network over a public network. Sounds like a mouthful. Anyways, let's go to the next slide, Ali, if you don't mind. So the end result of all that, and then I'm going to hand it over to Ali, who's going to do a lot more technical talking than I'm ever capable of doing. But the end result is to deploy networks in minutes, to reduce costs. And I think that's a conservative number, to be honest. No CapEx, so imagine going into a location or standing up a location, for some R&D team for 3 months and then exiting and not being locked into a contract. Instant connectivity to any cloud provider. So if you want to connect to AWS or Azure or your own VMware OpenStack deployment, we offer a vRouter instance. So depending on the type of throughput you require, we'll give you the specs on the VM you need to spin up, and then you just pull down that software. And then, like I said, customers want to be with us because they want to be. The services you use today should be because you want to, and they provide value, not because you have to or you're stuck. So I think we have the first use case coming up. Let's go to the first one. Then I'm going to hand this to Ali. Connected cars, I gave my little speech on what I think is connected versus autonomous. But we've had a couple of use cases. This is the first one here, which is the connected vehicle. And we're going to walk through kind of what that configuration looks like. So I talked about this network, and I talked about what it does and so on. But what the driver's seat and what the portal looks like is completely different. So Ali, thanks.
So before I go to the portal, I want to speak a little bit.
Let me give this to you. Sorry. Hold that. There you go, buddy.
Before I go to the portal, I want to talk about the example you're looking at. Basically, let's say you're a ride-sharing company or basically a trucking company. You want to track all the assets that you got. And currently, the easiest way to do this is basically to use an LTE or a 3G or IoT MP, whatever the new LTE technology available for that. Still one of the things, so let's assume I'm using provider one, who is providing me LTE signal. And my cars are in a region where coverage is not available for that provider. Maybe I'll get something through roaming, maybe not. My luck being connected will be lower. So basically, another thing that you'll see, we use multiple LTE in our use case here. So I'll switch the computer so we can stop building this. Before that, one really quick one, which is basically, you're gonna hear me talk about nodes and configuration and system objects. So just to give you an idea, what is the component inside the account. As who's familiar with AWS account, use their portal before, probably, yeah. So a good example, if you use AWS, you log into the portal, and you got a lot of resources that you can start creating immediately, whether that going directly to the marketplace, or basically by dragging some VMs and using a template to build. We got similar approach, but with a lot more that you can use with system object, which what we're gonna present to you guys today and show you how do I create the configuration despite what the node type is. So in the example we'll go with today, we'll start with multiple connected cars, and then we'll expand it more to the second use case, which we'll talk over. So can you hold this for me? Let's see if everything is ready. So basically this is the main portal. Basically, it's your way of getting inside the control panel. And I'll start by creating the AI-WAN fabric. To explain what the fabric is basically a container for the network that allows services that exist within the same fabric to share certain network segment. So when I talk about network segmentation, which we're going to look at in the configuration, think about a single backbone connection. You have one Ethernet connection or one cable going back to the internet. Let's say you got 3 or 4 different wireless and wired network. Each of them is serving different purpose. One of them is serving IoT. The other one is serving access for your platform, for example, access to your building. And another one is your billing. They shouldn't be on the same network. And we're not talking about creating different VLANs or creating basically some type of firewall between them. They basically use different routing table completely, altogether. And that will give basically more control to the user. That's what happened last time. What happened? Cannot. Can you make it bigger? It's a great resolution. It's fine. It will change. It's mobile. Don't worry about it. Somehow the resolution is lower now. Oh, that's the nice thing also. You can use it in any platform from your phone too. So I'm gonna start by adding my fabric, which is basically the main tool that I will use to build, and start by that. I'm clicking on add fabric. The GUI will exactly look like what it looked like on an iPad right now because of the resolution. So the fabric name will be you got the option to use a pre-designed stencil, ready to use. So basically, if you're ready to launch a segment that is basically MPLS based, you don't have to go through all the configuration. You can just use the stencil pre-ready made and create an MPLS network and add your nodes, and you're connected to the MPLS. Who's familiar with MPLS protocol? So basically, it's routing between location. You can enable basic routing using static or connected, or you can use routing protocols. And the other option is VPLS. There is no routing in this. It's switching instead. It looked like a switching to the end user, but there's actually more happening in the background from LDP perspective. The last one is MPLS, but with swarms, which is basically the technology that allow a drone or a car to become a controller, and other units stuck to it, basically. So I'm not going to use a stencil. I want to show you how easy it is to use it without a stencil. So my fabric is created. I have no cost associated with it yet. It's just new. I will start by adding a service to it. In order to launch my service, I'll go View Fabric, and I'm going to add a service here. Add service. And I'm gonna just add a basic network segment to start with, so I can build my MPLS. I'm gonna call it segment number 1. Which fabric it belongs to is the one we created already. We called it fabric 1. Segment is already created, and this is an infrastructure segment. So basically ready now. I can start building my configuration and get ready. Here we go. Let's go to the config. I'm going to click on configuration object. Before I go to the configuration object, one of the things that we see in the network today, you don't want to create a configuration for a location by what if you're managing 1,000 devices? We're talking about extending the devices that we have today to sensors, to everything. You're going to talk about millions of equipment connected per enterprise. How do you control all of this? How do you configure and manage all of this? So the idea of being able to use configuration template, make it easier for you to do that configuration. On the same time, that template is not just a basic CLI. You're allowed to actually to inject what we refer to as system objects. These objects allow you to control the configuration and use it in different nodes by deciding what's variable in your design. So let's say you decide a template and the only thing variable is probably subnet and VLAN assignment on that level. I'll create an example here where we have different subnet in each location. System object will be LAN. And I got multiple type for the object. I got object type of variable object where I can define that as variable and it will not be used till I'm ready to add the node, but there's some type of static object that you use in the network. DNS, for example, or your PPX IP addresses. It's the same among the multiple nodes that you have. So you don't need really to create a variable one. In my case, I need a variable one. So I can make it different between locations. So I got the variable object created. I'm gonna go home and create my configuration. So a configuration template. And one of the nice things about the configuration template is it's basically text. You can copy it, you can share it. It's very easy to share. And basically I specify the fabric here for a reason so it can fetch all the resources in that fabric, whether that's the network segment that I already created. It will link all the available resources inside the fabric and make it available for me to call in any configuration that I make. Network configuration, also you can use stencil for sure. Make it easier for that. So you got SDI configuration, SDI with fast path. And we have the hybrid solution. A lot of customers already have existing AT&T MPLS, Verizon, whatever existing circuit. We're not asking the customer to actually get rid of that. You can keep it and use it for traffic alongside cheap cable and other options and decide what goes on what. Which basically creating an SD-WAN policy as part of the configuration to say Facebook traffic goes here, YouTube goes here, my real-time Skype, Office 365 will use the best connection. So these policies basically allow you to do that. I'm creating an AI1 config, but without a stencil. So you can see all the config in. So basically this is a basic configuration here that we can look at, and it giving you an example of what the configuration may look like. And basically the config is, let's say you got two internet connections, basic cable, and both are giving you configuration through DHCP. And then you got a third connection which is acting as a LAN, basically setting up a basic LAN server. And this is where it get a little bit more when you control how do you load balance. How do you say this link is broken? What is your threshold? You control all of this for each internet connection, or you can leave it at auto. Let the AI basically figure that out using the regression algorithm and watching all the traffic as it goes, calculating for packet loss, latency changes, bandwidth availability, and as Wes explained, when we said we are in these data centers, we leverage IP transit. A lot of people familiar with IP transit, we buy BGP and we look at every single provider that we peer with. So we see how we can reach point A based on the information that we collected and we have on the network behavior. All these nodes that we have on the edge, collect that data and send it back to centralized location to affect routing and affect the way LDP switch packets between location. This is why when Wes was showing the map, there was no links. These links can change based on how the network is doing right now. Switching between, for example, Seattle and LA will change the route as the traffic change around 4 o'clock every day. And we've seen this behavior happen all the time. Business before it closed, they do a lot of settlement and credit card and a lot of things. And basically that push a lot of data during that time, or backup get engaged in a lot of business during, at night, for example. You'll think the network will be very quiet at night. But thanks to AI, actually, you see these stats, and now you can route around it. Your routing decision is actually no longer based on subnet, is no longer based on destination, it's basically based on that. SMRP is actually the protocol we use, and me and Wes was talking about the autonomous behavior inside when we refer to like autonomous car. Is it really autonomous? In our case, I will say the router is 85% autonomous. That's based on preloaded. Wait, if you guys familiar, who's familiar with darknet here? Did anyone use darknet before? Okay, so basically darknet is an example, came out from Google Labs to allow people to actually do object detection in real time. And it's one of the examples we usually show on Movidius, on the VPU, to show you why this device make a lot of difference and it's gonna change a lot of things we see today. Because we see one thing, our attention is based on how fast our eye refresh and how fast our brain, but when it comes to AI, it's different. So again, you got ASMR, which is basically the autonomous secure multipath routing, by 3 internet connection or 2 internet connection and leverage LTE. And again, AI learned that, again, LTE is a meter service. You shouldn't be sending all the data all the time unless you have no other option. It will be the less used option. So when we talk about MEC, there is even opportunity to say, provider A and B do a limited, but not in everything. So if I have a YouTube traffic, where do I send it? Which network have a limited YouTube or a certain agreement? Make that decision based on app. Give the user the ability to do that design. So basically this part is ready. I can start using it immediately now in creating the node configuration. Before I go there, I'll change one thing for my Ethernet side to have the LAN side subnet being variable. I don't want it to be static. And this example is text ready to be used here. I'm just gonna delete this. So I want to use the system object that I created here instead of giving the IP address and the config. It's just an example. That could be your VLAN, that could be your entire configuration as variables. So let's say the service provider is one segment that we usually target. You can create all available configuration, have them as a stencil. As your user go, they will decide, do I go MPLS? Do I need VPLS or do I need something else? I'm gonna link the object from the system here. So this is insert system object. I only have one that I just created. Click add. So basically my IP address will equal to whatever the value of that system object on that site. If I need to add any information about this, for the version, you can create multiple versions of the configuration. You got built-in version control. Okay, so the config is saved and is ready. We can go and look at node deployment, which basically will be the last piece. And then we'll stop a little bit and talk about how all this click together. Why is it good?
Yeah, okay. So while Ali's doing that, so one of the good things is that a lot of drop down, a lot of GUI interfaces have buttons that you click and so on, and you find difficulty in sharing configurations. And so with the command line here, it allows you just to email or text or share that configuration, have somebody fix it, add something, and then put it back in into the portal here. And in addition to that, the interface for the command line is intuitive. So whether you want to type 1 megabit per second and spell it all out, or you want to type 1 meg or 1 Mbps, however you want to do it, it's intuitive. So you don't have to learn a new language, a new command line language at all. This will do it for you.
Yeah. So as an example, when we talk about nodes, what is these nodes could be? I actually, for the example we're following, it could be a car or it could be a drone, because one of the things that we start looking into is like, how do I give the drone more vision, more ability to detect everything without needing the connection? This thing is flying in the air. There is no guarantee we'll have signal back to the data center or we'll have signal back to the controller. There's a very good chance you will lose signal. So one of the things on that drone, we use the Intel platform for drones, and we build a good use case here where we actually 2 LTE LoRa, and I noticed someone was talking about SDR. That's the nice thing also. It's an SDR radio on board. So if you decided you're actually running a LoRa stack, you're in the US, you're running on 15 megahertz, or maybe in Europe, you're running on different stack, it's all software defined. So I'm gonna go ahead and add the node by clicking on add node. Basically the information that I get presented in case if I'm adding bulk number of nodes, I don't want to do that one by one. So basically, I can do that all together. And which fabric this node gonna belong to, in my case, is the one that I just created, which called number 1, fab 1. I need one node to be created now, and I'm ready to set up that node. Just basic node information related to where it's, think about this as data keeping, so you can keep tracking of where is what and how this work and how the alarms get generated and all. So this is node number 1. Okay.
So just to kind of recap what we did, we built an AI WAN, which is a container for everything. We built a configuration template that can be pulled in, right? And we'll do the equipment as well. But essentially, everything is kind of, you can do it in either order. You can have configurations done. You can have nodes built in advance. All these things, there's no specific order that you have to follow other than you're just taking all the building blocks and putting them together. And when you build the node architecture is actually what brings all of those together. The configuration, the equipment, the network segment, and the AI WAN fabric. And once all of those are brought together, it's just the drop down to select those. It becomes, we're doing it from scratch here, but it becomes a matter of, 30 seconds or so.
Yeah. So basically, after, as was said, after the template is created, you're no longer doing the work anymore. And also that can bring more opportunity for the provider, for the service provider, to have all these basic templates. The use cases are mostly identified by the backbone connection. What are you using to connect? Are you into routing with MPLS or just basic internet access? And you want to prioritize application. So I'm using AI WAN in this case. The difference between the operating mode, SDMAC obviously allow you to deploy VM, containers, Dockers, any type of application all the way to the edge, which that edge could be, as I said, a drone, a car, a router, or a bare metal device sitting on site. So the node is basically the remote end, the location sitting outside the data center. I have nothing to do with the data center. So AI WAN. So basically, I got the information saved. I'm ready to add my device now. If you have existing network equipment, you can just drag the network device and add it. If you're ordering new equipment, you don't have to worry about how this get ordered. You just add it, and that will show up in your system, and you can order it. I'm going to use a new Netrolix device. So NID is the device that we refer to as a network interface device. It's an old term we used to use in the telecom days of the ADSL and the T1. The reason we call it that, if you already bought equipment, if you already invested into a Cisco platform or a Juniper platform or FortiGate platform, it's illogical to actually say you cannot use any of that anymore and your entire setup needs to change. The NID is basically just sitting in front of that, connected to the LAN. Keep your existing setup. If you're ripping off MPLS from an existing service provider and you're replacing it with this, or you're adding a backup to it, or increasing your bandwidth, it will become very easy to do. Just adding another port, that's all. So NID number 1. And configuration template is the configuration I created. And basically after that, I choose the version of the template. I only have one, version 1. If you got multiple versions, you can actually control which version you use. And that give you the ability to do migration. So another example, especially in the retailer sector and enterprise, they do project until the equipment rolled out. They are not ready to do that setup. They are adding signage, for example, or changing the POS. That could be just a config already saved, and when the equipment is ready, the network admin is just gonna flip which configuration version to use, and that will update its configuration. So as you see, as soon as I selected the configuration version, the template version, it's asking me for that variable that I injected in the template. So now basically I can add as many variables and ask the end. Remember, this is what the end user doing. The variable usually, or the template is usually what the admin is preparing. So you're given both an interface. The admin can prepare everything. Let's say that's in the headquarters of the company, the people who design the network. And then the regional end user, just basically entering data. You don't really need that deep technical background anymore to do this. So back to that, I'm gonna add the subnet. Just an example here. And this information you see here is based on which device I chose, because I selected NID1. What you see here is the number of interfaces on that. This is a very basic device, and basically it offers up to 100 megabit per second of secure throughput. This is IPsec AES-256 as an encryption, but one of the nice thing about it, the onboarding technique is using elliptical curve. It's using a chip. The onboarding of that router is like a SIM card. You have today, you take that SIM card, put in the smartphone, zero touch. You maybe not even need to call AT&T or T-Mobile to activate it. Maybe you do, but it's just the activation. Same idea. It's one of the issues we focus. How do we authenticate the device? Especially if these are getting shipped internationally. How do you make sure that device doesn't get interrupted anywhere? At customs, at somewhere else, and the firmware get changed. Someone removed the firmware. We use Intel Secure Boot, of course, that protecting against a lot of that. But the main thing that we depend on to do this, something very similar to SIM card. Same behavior, it got a PKI, it's Java card based. Who's familiar with Java card? It's the platform everyone uses every day today in their new credit card, debit card, the chip that you see there. That's Java card. It's based on an Oracle system. So we use the same thing. Very similar approach, give you more security. So now my device is ready. I got my device added and my configuration is set up. At any time during my life cycle of the project, let's say I decided, my subnets are not large enough. That was a problem in any network if you guys seen this in like 10, 15 years ago. That's a project on its own, can take a whole 2 or 3 months just re-IPing the network. Right now, if I want to change the IP address, just give it a new IP address. Or if I want to change the VLAN, it's just changing the VLAN directly and that will push the update. Or I can even schedule the update and when it get pushed. So for now, I will stop at this point and let us talk about the second use case. I want to show you the device. So this is the vehicle, the one for the connected car, basically. So you see that the antennas is for the LoRa and LTE, and it's XLTE. So basically, I can combine 2, 3, 4, 5, 6 channels using Ethernet over IP techniques and utilizing and make it look like a single channel. 200 meg over LTE may seems like, how can you do that? It's not possible. It is actually, it's just multi-path TCP. If you guys familiar with the update to TCP protocol now, TCP can use all existing connection and send traffic over that. On the other side here, you can see also there is an HDMI connection. This is also designed to be like an entertainment center. It's equipped with Intel GPU, basically the built-in in the CPU, but we're thinking about this as the car may end up being an entertainment center. Not necessarily just a car, a bus, or anything that move on the road. It's giving you more, it's showing you more. The other example, let me show the other one. The drone, you can disconnect it. Yeah.
So a couple of things that we learned while we do that. So one thing we learned is that this whole AI WAN fabric and architecture we design can be pulled out of the current existing deployment today and or integrated with a private architecture. So that's going to be our next use case, right? But what that means is I no longer just have an AI WAN that extends over the public internet. I have an AI WAN that extends over a private LoRa, like Ali was talking about, a private city Wi-Fi or local campus Wi-Fi. I have a platform that can operate on LTE, that can fail over from LTE, to LoRa and vice versa, and to Wi-Fi, and have a multi-access methodology for that network connectivity to that endpoint. So when you talk about tracking buses and scheduling and maintenance for buses, or when you talk about just the connected vehicle, right? In general, right? That's where we say, hey, you know, the network is going to evolve with those technologies, and hopefully we can be a part of that.
So this is a perfect example. This is an Intel-based platform, and here you got a full computer with 1 terabyte of storage, SSD of course, and 2-channel LTE, 2-channel Wi-Fi, and LoRa. So basically this thing can be in the air and I can control it from somewhere else, different place. And thanks to the software behavior, which we can load the same software we actually load on the router, this can act as a controller for a multiple drone. They don't need to communicate to the base. They can communicate to what we call the coordinator in case if you are launching a drone swarm, and if the coordinator gets shut down or fail for whatever reason, they elect another coordinator. Save communication, only send the data you detect. Of course, this one is also equipped with RealSense, Intel RealSense, so the drone can see depth, which means it can avoid all kind of obstacles in front of it, and also it can detect people thanks to Intel Movidius, which is on chip added by us. Basically, you have a full-time AI that you can control from the network. This is a VPU, real-time object detection. Anything you can run today on a VPU, basically, you can run it on this basic platform. And this is just an example. There will be more connected vehicles, more connected drones, and more examples that we're gonna speak on, especially the Earth station, the ground station that you look at, which is another challenge in the next movement for the drones. How do you make sure this connect to the right place and charge? And Wes talked about blockchain. We're looking into blockchain applications there. Like the contract for this drone sitting on the charger until it leave. That's how it pays using blockchain. And there's more use application that we can introduce, but basically using SD-Back, you got an application running on Docker, you can put it here. You got an application running on a VM, you can put it here. All communicate to any centralized location, whether that's AWS or Azure. Of course, you can leverage all AI services over there. That communication is done over IPsec. That IPsec encryption is not using a key, is not using a cert. You're worried about that cert being compromised, that key go out, a username, but none of that is used. The 5-factor authentication is used, is all hardware-based, and standard zero-touch onboarding behavior that you're gonna see in most network equipment soon. Protect it and make it look like basically a smartphone. So, back to you, Wes.
Thanks. So when you think about building a node, we used to think about putting a brick and mortar, you know, office or a Starbucks or a retail location or a local corporate office or whatever. The drone is a node, right? And the vehicle is a node, the office is a node. These are all just connected, and essentially the intelligence being built by Intel and the platforms that are there today are essentially pushing everything out in the intelligence to where we're creating essentially micro data centers, right, through edge compute, right? And so when you see the nodes being built, I mean, essentially that's a connected device. It's a drone, it's a vehicle. And Ali, I don't know if you want to talk a little bit more about kind of how that looks from a fabric perspective.
Yeah, but so we can talk more about like what type. I mean, to me as a leader of a dev team, one of the things my team will ask, like, how you're doing this? How you're actually using AI to predict network behavior or study network behavior? I mean, you're dealing with, basically what we're collecting is latency, packet loss, jitter based on that. How the peering point between providers and the data center we're in look like based on how the traffic is flowing from us to these other providers and based on the incoming traffic. So you have an idea overall. We reached back to the darknet example that I usually take. The reason I take that example, darknet generated pre-calculated weights that basically you can load in Python or any language you're using, and you can actually use it for live object detection. We generated the same idea calculated weight using linear aggregation, basically multiple linear regression algorithms that allows to smooth the output and take out anything that counted as an anomaly, but usually it's a normal behavior in an LTE. AI still doesn't see this as a normal behavior when an LTE circuit start giving 100 millisecond or above 100 millisecond latency. It's just because a truck is passing by, and it will cause that normally. So basically that 15% that we left is what the device learned on site. Each circuit is different, especially if you're talking about cable. The quality of the cable in each area is totally different. The stability of that cable and how much bandwidth you get is different. We both came from service provider field, and we know how these networks are built and how this network get expanded too. The expansion and the number of users get added. You need some intelligence to select the best route for the next 10, 15 minutes, which may change. That's the thing. We don't route based on pre-configured configuration. As I said, the subnet is no longer your judge. You're not just looking at 000 and you're following that, or you're looking at a /24 and deciding this is how I'm sending the traffic. That's no longer the case. And the existing routing protocol, that was one of the reasons that actually pushed us to move to our own hardware. And let's remember this, existing routing protocol, whether it's BGP, OSPF, or any other routing protocol in the market today, pre-configured. Most of these are pre-configured. Even if there's a learning behavior, is based on calculating information that relate to how far you are. What is the shortest path? It got nothing to do or doesn't even understand changes in the behavior. Recently, of course, there was new routing protocols getting invented, but so far nothing changed on the internet core. Internet core is still the same. And the only way we're gonna push AI to the edge is basically being able to connect to that device in any other ways. And the other big push, and we saw that today in multiple events we attended, MEC, it's gaining more traction. MEC basically, it's the way that you're gonna bring this stuff from the cloud down and do most of your processing. So if I'm teaching a camera on, let's say in a school, and to know the kids that usually come to school every day and detect anyone never seen before. That will take a lot of data to be uploaded to the cloud, adding to that the security and the privacy of that. But if I'm doing all this training locally on that machine, on that MEC device, using an Intel-based Movidius VPU dual, 4 or 5 or 6 of them stacked on a USB stick, basically I have more than 20 frames per second in real life, real time, that you can actually see 20 people on the same time, recognize that. Still, I didn't send that picture to the clouds, neither got into the laws that we see today, and Wes is very familiar with it, and a lot of people see it. There is a lot of countries and a lot of regions are trying to keep the data locally. How are you gonna keep the data locally if you are using cloud or you're using SaaS application? You're stepping into a new area, like especially in European Union right now. MEC is a perfect example. Keep everything inside your network, doesn't matter where. The edge, the cloud, or anywhere it is, it's one network, it belongs to you, your data, you control it, and you have full visibility to it. And of course, fault tolerance that you can actually use to make the network very stable. Back to us. So let's go for questions. We talked to
yeah. I can't do it quiet. I was actually set it on one mic so I could take it away so that you didn't want a conference call. But we do want to open it up to questions. And I know we've got a lot of time left. We can accelerate it through that a little bit faster than anticipated, but that's okay. So if you guys have gals have some questions, definitely feel free to ask, or please speed this up as much as possible. I see it's like, these AT&T is going to get us.
Go ahead.
Ali, good job. Your fast picking is okay with me.
Thank you.
Good presentation, good things that you're doing. How does a customer get billed? Your client gets billed, what are the billing issues there, and billing anomalies that the customer sees, how do you do all of that? And especially because you're doing everything, like AI, but, I don't know how much of that is AI versus program. And that also I want to understand the paradigm of your real AI
Yeah.
versus only program part.
So I mean,
Continuously learning is different.
Yeah, so look, I'll talk about
Hit the billing,
and then
yeah.
I'll talk about that.
yeah.
No, from a billing perspective, we try to be very AWS-esque in that, someone will say we're gonna add 50 sites, I say, that's fantastic, why are you calling me, right? And the fact is, so there's 3 billing components, one of which is an initial 5 meg port into our network that you pay a base fee for. That 5 meg is CIR, so committed information rate, it's not a license. The analogy I think we used before with Debbie was, look, if I give you a Ferrari and I park it out in front of this building, and I give you a license for 200 miles an hour, well, it's about that time. You're not gonna see 200 miles an hour anywhere in the city, right? Even if you have a license, who cares? So a license on a box is irrelevant as far as we're concerned. So to us, we bill on CIR, so the initial 5 meg, and then it's a per meg fee of committed information rate, not usage. So you don't have to manage it, so you just order a 10 meg, 20 meg, 100 meg, and you can increase that at any time. You can bring it down, but we do that, and then there is a device fee, a monthly fee, which is a small fee as well, and it's an OpEx model. So, and the reason that we separate that when we deliver service is because some folks just want a NID. They just want, 4-port, maybe they want 24-port type device, and others may want.
Or that may
FTU,
change.
Some don't, and that may change, right, exactly. So there has to be a separate pricing. So three elements. The initial port, actually there's 4, there's 3 for each site, which is the port, the 5 meg, price per meg, and then the equipment. And then there is a network fee, which is just a resource fee. So if you order, say, an MPLS network segment, it's anywhere from 2 to 500 locations. It's like a flat $200. It's just for the compute resource fee for that network, right? So, and I know, go ahead.
Thanks, you talked about pricing, not billing.
Oh, so.
Billing management, billing, whatever billing operation system.
I mean, I can talk more. So basically, so the billing information and the billing data that get generated by the platform, the user can set up billing rules. So you can set up what is the maximum to trigger any type of anomaly to see basically if your billing is above certain things, especially if you use one of these services. You can spend something on AWS or on Azure and basically you didn't select the right VM. Just that is enough to actually give you $500 bill you didn't expect. I mean, these stuff basically, the user get notified too if they set up a preset value so they can get notified of. Also, the billing system itself is basically an API that we utilize that leverage more data that can be passed to forwarded, like fraud detection, anything that someone may be trying to mimic the user site and add a note under that account, which usually doesn't happen because the PKI and the chip that on the router, as soon as you pull the SIM card, like the smartphone SIM card, if you take it out, you can put it in different smartphone. If it's unlocked, you're fine. If you take the SIM card out, it's burned.
So, hey, one last thing.
Yeah.
So one last thing for the service provider, because it sounds we're very competitive to a service provider and maybe to an equipment manufacturer, and the fact is we are. However, we also operate really nicely in that space as well. So as an example, if a customer had a global AT&T network and they wanted to use a backup or a secondary network, or for places that are just tough to get to or cost prohibitive, we can deploy in those locations and do full back-to-back NNIs, option A, B, and C into the network. So essentially that private MPLS from AT&T could extend across our AI-WAN and be that same VRF, right?
Yeah.
So we operate really well in that space as well when we're operating with service providers. So.
And the AI piece, I want to basically explain. We keep use that term very, very everywhere, basically. It's deep learning. What we're referring to is deep learning. It's based on TensorFlow and Caffe, basically. And the pre-calculated model that we designed is based on a supervised training model that we've been building for a while, running that on 20,000 data collection point globally. Different ISPs, technically most ISPs, we've seen the way they behave and how this changed in about an hour. Most ISPs, the behavior, especially the let's say the metro ones, they change the behavior getting ready for the entertainment session. Everyone is hitting Netflix and Hulu and all of that data. People expect they are causing that, but it's basically not enough available data. You have to adjust and adapt to it. Our system will see it as an anomaly and use different data center. Your latency may look a little bit different, but you're pushing the bandwidth you're looking for. So, next one, yes, sir.
Question for the,
Go ahead.
I saw you define the interfaces based on the internet, so wide MPLS, all kind of thing, and the load balancer, right? Can I define QoS? Or you just apply it end-to-end? If something goes on packet loss and latency, you can steer traffic.
Yeah, so basically let's say the collection of data and the identification of error or fault, it doesn't happen in one segment. So the device is basically speaking to all the nodes within the same segment and checking the behavior and the performance, latency, jitter, packet loss. More than that, actually, one of the things that we monitor is like what's going on with TCP windowing, how TCP windowing is behaving, and that's one of the things we look. You don't have to look at anything other than the packet header itself. It will tell you a lot of information about what this packet is doing, why there is a lot of free transmission, and basically you can start giving the user an idea where this fault is happening. Is it actually on the first side? Because remember, we only use the internet, and I think that's something basically not easy to see in here. The internet is only used for the last mile. It's from your device to my PE, and PE basically is the provider edge device. We're placing these into data centers where the service providers, Comcast, is letting the traffic out to the public internet. It's sitting there. So basically in Seattle, as a good example, I live in Portland. I got a PE in Portland. And if I look at the latency to that PE, you will expect it's literally 5 miles away where the building where they keep this equipment is, the data center. But my latency to the PE in Seattle is better. And one of the things that like you will not think about, Comcast I use Comcast at home. They send all the traffic to Seattle. It doesn't make sense to exit to Portland, it's a small city. You don't have that much traffic. Your traffic is going to Seattle anyway. So I'm watching end to end, not just one piece of it. Hopefully I answered you. Thank you. Go ahead.
So a good example of that is, take Omaha in the United States. If I asked you guys to give me 2 major companies that are headquartered in Omaha, besides the university, that's tough. However, network-wise, and that's why on our map you don't see lines and paths, because our network is deployed currently based on 2 things: customer need, where we have to be more dense, and secondly, based on internet routes, not based on geography. So we're in Omaha, but not because we have a big customer in Omaha. We're there because it's a major transit point for internet traffic in the United States. Right? So it's a little different. So.
Third-party entities, hardware entities, interconnect with what you guys are doing?
With regards to like a route, like a Cisco router, or like a FortiGate platform, or
Well, I do SDR, so I can do a lot of the
So,
support.
I mean, we use SDR, we use Lime microsystem, chipset. Okay, you know what I'm talking about. So, we use Lime microsystem, the 7000 actually. I'm hardware. I come from hardware design. I'm using the 7002M, and I'm using it to actually mimic LoRa. UTMS is still shaky on it. I'm not really interested in it, but I'm interested in LoRa and RFID. And that drone that I show you already equipped with that on the chip. Basically, it's configurable, of course, with an FPGA. I got an Altera 10 in there. So again, it's all Intel product that we are actually leveraging. And again, the user can choose software-wise. We are personally and in the company, we are very interested into SD related because we see the future happening. No way you're gonna install like complete RAN systems everywhere. It's not gonna happen. It's a lot of cost for 5G. The micro cells, another use example, we talked about how the connected car are gonna pass all their data back to the data center. You need that data to train. AI need to train. You're not gonna have, self-driving car right away. We're talking about 25 gigabit per mile on average. Go ahead.
Back to my question.
Yeah.
How could can the third-party hardware be interconnected with you guys?
There is, so we have a northbound bridge interface by I2, whatever interface you guys are actually, USB, USB 3, even some of the new interlinking interfaces for anything above 100 gig, which is not radio, of course. But there is an interface and there is an API allow third party to bring their equipment, or let's say their product, their models. Because another thing we looked at also, there's a lot of models that offer both LoRa, Sigfox, and LTE, and Wi-Fi. Very interesting, but still, when you have a drone, no way you're gonna load models and models. You're gonna have one radio, one RF elements, few balloons, basically. You control all of that through software. And I'm sure that's what you guys do. Go ahead.
Based in Chicago
Yeah.
as well, and I just got through spending.
We are in Chicago too, so
White
interesting.
Sox? Are you White Sox?
I'm north side. Long story short, I just spent 3-4 hours with Ford.
Yeah.
I don't have the interest of Ford to give you an idea.
We'll talk. I mean, definitely we have to. SDR is the future. Without SDR, a lot of people maybe don't see it yet. Without SDR, 5G will take forever to be deployed. Micro cells is 5G.
Here, real quick fact that everybody probably is not aware of. 60% of the United States mobile phone towers are still on dial-up. So when you hear all this stuff
Absolutely.
about
Yeah, that's true.
floating and everything, it's gonna
That's
be years.
perfect for the
You might
edge.
have 5G around the block in a major metropolitan area, but it's not gonna be universal.
You
Because the infrastructure providers have to open up their fiber, their broadband.
You got it.
So-
You got it. I mean, that's one of the main use cases. Oh, sorry. So one of the main use cases when we talk about connected vehicle, and probably you guys already seen what is the problem for the car manufacturing right now. There is a car already on the road today, Volvo, the self-driving one. It generates about 25 gigabyte of data per mile. Okay, let's assume you're saving that data locally on a device. And how much storage you're gonna have? You have to get rid of that as fast as possible. So we thought about an example where we show a city, a built example, where we actually have an SD MAC in the traffic light. Each traffic light will have an SD MAC. Think about it as a microcell, right? It's an SDR, and basically, let's say it's operated by, a certain operator. It doesn't matter who bring the hardware and the software. These cars, when they stop, how long is it spent? 2 minutes? 1 minute on average? That's enough to send a lot of data if you're running on AC Wave 2. 2 gig, by the way, tested on that. So you get what I'm talking about. Thank you. You got it.
Any other questions from anybody? I know he probably has some. All kidding aside, listen, we appreciate your time, and we're gonna be around for a while afterwards, so definitely feel free to come and chat with us and talk with us. All these ideas that we're talking about, they're just use cases. We're just the network. We're just facilitating an output. So we're just facilitating the flow, right? We're not gonna make any drones or we're not gonna do that, right? However, we do want to facilitate the connectivity, right? And we do want to leverage a powerful core compute platform, right? However, we just want to do the network, right? We want to make all that work a lot better. And so thanks for the time. I appreciate it. Thanks, John.
Thank you. This one for you. No, that's for you as a speaker. Those are speaker gifts. Thank you so much. So is Michelle here? Yeah. So some more raffle prizes. Yeah. And then Idea Relay, so Michelle will be handing over the Idea Relay cards. Okay. Okay. So I don't have that slide right now with me, but once you get the cards, you'll know what